Alright users, just going to do a quick one take, hopefully, tutorial on how to use an infrared image as a luminance layer for planetary. I just figured this out. It is really nice. So I took a few 3-minute videos of Mars, and all I did was stack them in Auto Stacker, and I did some with the ProPlanet 742 and then one with just the UV IR cut. So we'll open up both the this is the infrared image and this is the color image with just the cut filter, the UV IR cut filter in it. And this is how I do it. It works for me. I don't know if this is the best way to do it, but it's quick and easy. We'll just click on our infrared image, hit this button up here to extract the luminance channel. So this is a grayscale image of the luminance for our infrared. Then I go ahead and save that in our registered file, in the registered folder, and then go to our RGB and hit this button right here to extract the RGB channels. Now we have to save all these first because the starless alignment script only operates on files. It doesn't operate on views. So save these in your main folder. And close them to get them out of the way. And now what we need to do is align all of these images, because I had to take my filter out, and even if you're using a filter wheel, Auto Stacker may have, like if wind blew you a little bit, you know, your two images might not be perfectly aligned. So we need to align them before we do anything else. I tried sharpening and then aligning and stacking after sharpening, and that caused some weird artifacts because that, you know, it just didn't work out for me. So we go to Script, Utilities, FFT Registration. I don't know what that stands for, but this is what it works. Oh, Fourier based image registration. Okay, reference image. We will use our luminance layer as the reference image, and then we will open up our RGB channels for the ones we want to register. Now we will write registered images, correct for rotation, do not integrate register, correct for scaling, and then select our output directory, registered, okay. And then we run that, and it will then align our channels. And that should be that. So I'm going to leave this open so we can do a test on it. Okay, so now in our registered we have our luminance and our RGB channels. Now what we will do is go to which one is it? Channel management, color spaces. Color spaces, LRGB combination. And I'm doing this in Pixinsight, but this is a fairly straightforward process that you can do in any, you know, you can do it in Photoshop, GIMP, whatever. I like Pixinsight because multi-scale linear transform is like my favorite tool ever. But anyways, open up your LRGB combination, and we'll go ahead and select our files. We can't, okay, these have to be opened. Okay, I thought we could select files. But anyways, okay, so we will go ahead and open up all our registered images. Okay, now for our luminance, we select our L, obviously. Red channel, now when it registers it puts them at an R after it, so make sure you select your actual red channel and not the one that it put an R behind. Actual green channel, actual blue channel, and then just hit apply global, and it will combine everything. Now for some reason my green channel is really strong here, so it's really green, so I'm going to dial this back a little bit and see how it looks. Combine, that's better, that's close. What about a little bit lower? That's pretty good. We'll call that good. Okay, so this is our infrared as our luminance channel, and the RGB from the UV IR cut filter, and this was all taken with the same ASI 224 MC, and that is the combined image. Now we can go ahead and sharpen, multi-scale linear transform. Now this will take some fiddling. That looks pretty good. What if we try to de-ring it a little bit? See, that kills the ice cap. You know, that's not bad. That's not bad. I think we'll call that good for now. Okay, so I mean that's basically it. You can. It's got kind of a black ring around it too. I'm going to try. Let's try to soften it a little bit and see if that. Okay, yeah, that knocks that artifact down out there. Let me see. Yeah, that looks good. Okay, now you can go and adjust your saturation, and just to show you how big of a difference that infrared makes, we will do the same processes on this one, on the original color image, without the luminance, without the infrared luminance layer. You can see what a difference that makes. The color is obviously messed up. Just kill the green a little bit. But yeah, I mean the features on the Martian surface look so much clearer with the infrared as a luminance layer. It looks good. That looks cool. Now, it's a little pink. You know, that's easy to fix with saturation and stuff. But otherwise, I mean, it's really easy to do. That looks pretty good. Let's try to knock down the green a little bit. looks kind of weird around the edge. I mean, that's really zoomed in. When it's out to normal size, it looks fine. But yeah, anyways, you'll have to play with the colors, of course, but it makes a huge difference on the surface detail. Yeah, that came from the color data. You know, that's probably because my atmospheric dispersion corrector wasn't dialed in perfectly. My channels might be a little jacked up here. But yeah, that's how you do it. That's how you combine your, use your infrared filter to add that extra detail to the surface. And that was the Pro Planet 742 IR. This one, I think it was like, I don't know, it was less than $100, I think. And then I got the color data just with a, like it was like a $40 UV IR cut filter, but it makes a huge difference. So there you go, clear skies. See you next time.